Education Society, redefining excellence.
Hello, myself Abhishek Shudas Koril, studying in Zeal Polytechnic Pune. I am from third year of Mechanical Engineering. According to our project-based learning activity, today I am going to present a PowerPoint presentation regarding to our micro project for the subject of industrial hydraulic and pneumatic. So let's begin. Hello, today I am here to present you a project presentation based on our micro project. The title of our project is Case study on automation of pneumatic bench vise used in carpentry or fitting shop. This PPT was created by the students of Zeal Polytechnic by Abhishek Shivdas Kuril, Gayatri Rajesh Deshmukh, Akhilesh Pradeep Zadav, and Pravanjan Loknath Katote. This PPT is guided by Professor V.L. Sapkal and Professor T.Y. Garde. This PPT contained introduction, what is pneumatic system and its component, construction, working principle, disadvantages, objectives, and conclusion. So, let us start with the introduction. A pneumatic vise is a mechanical screw apparatus used for holding or clamping a workpiece to allow work to be performed with tools such as saws, planes, drill, mill, etc. Vices usually have one fixed jaw and another parallel jaw which is moved towards or away from the fixed jaw by the help of screw. Vice is used to drill wood or metal. By holding a workpiece tightly, it gives you all the stability you need so that you can make precise cut easily. Now, let us see what is pneumatic system. A pneumatic system is a collection of interconnected components using compressed air to do work for automated equipment. This work is produced in the form of linear or rotary motion. The compressed air or pressurized gas is usually filtered and dried to protect the cylinders, actuators, tools, and bladder performing the work. Sometimes application requires a lubrication device that adds an oil mist to the closed pressurized system. Examples can be found in industrial manufacturing, a home garage, or in dentist office. In this machine, a pneumatic system provides a simple and cost-effective means to move, clamp, rotate, grind, and screw. Now, let's have a look on the main component of pneumatic system. This group of components can be divided into five categories according to their function in the pneumatic circuit. First, the supply elements. These elements are the sources of power that drive the system, which are compressors. Second, the input elements. These elements are used to send signals to the final control elements and come into two forms, either such as component that is actuated by operator like push buttons or sensor that determine the status of the power elements such as limit switches and proximity sensor. Third, processing elements. These elements may perform operation on the output signal before sending the signal to the final control elements such as non-return valves, directional control valves, and pressure control valves. Fourth, final control elements to control the motion of actuator such as directional control valves. Fifth, the power elements, which is also known as actuators. These are the outputs of the pneumatic system which use the stored potential energy to perform the certain tasks such as pneumatic cylinders and motors. Construction. The figure shows automatic pneumatic vise. The automatic pneumatic vise consists of pneumatic cylinder, solenoid valve, flow control valve, PV tube, moving jaw, fixed jaw, and a workpiece. Working principle of automated pneumatic vise. The compressed air from the compressor reaches the solenoid valve. The solenoid valve changes the direction of the flow according to the signal from the timing device. The compressed air passes through the 5x2 solenoid valve. 5x2 means 5 ports and 2 position solenoid valve, and it is admitted into the front end of the cylinder block. The air pushes the piston for the workpiece clamping. At the end of the stroke, air from the solenoid valve reaches the rear end of the cylinder block. The pressure remains the same, but the air is less due to the presence of piston rod. This exerts the greater pressure on the piston, pushing it in a faster rate, thus enabling faster return stroke. The compressed air passes through 5x2 solenoid valve and it admitted into the front end of the cylinder block. The air pushes the piston so that the workpiece is lifted. At the end of the lifting stroke, air from the solenoid valve reaches the rear end of the cylinder block. The pressure remains the same, but the area is less due to the presence of piston rod. This exerts a greater pressure on the piston, pushing it faster and enabling the faster return stroke. The stroke length of the piston can be changed by making suitable adjustment in the timer. Now, let us see the disadvantages of pneumatic valves. The initial cost is higher, maybe a choice of air leakage or we can say air loss. Cylinder stroke length is constant. Now, let us see the objective gain while performing the experiment. First of all, idle time of the machine is reduced. When compared to the mechanical vices, it consumes less time for clamping and uncoupling the job. It reduces the manual labor. Hence, the production rate is higher. In this mechanism, there is no backlash. Extremely high clamping force. Conclusion. The project thus gives a system that can easily fix the workpiece and worked on it. The pneumatic valves provide extremely high clamping force and high accuracy and repeatability. Pneumatic system can get high production rate. When compressed air is released from the pneumatic components, hence operation of pneumatic system does not produce any pollutant. Thank you.